looking at the axis that there's sort of.
I saw it because it had the scatter plot, it had the equation for it. These exit slips are in beta mode right now, and I didn't think the question was bad.
No, it wasn't.
But I think when you make a judgment on how to adjust a lesson, that may just changes what it is, because the purpose really, especially in statistics, a lot of it is conceptual. It's not necessarily I have to manually plot that. You want the kids to be able to interpret a graph.
Correct.
And so it's really about interpretation more than it is about okay, let me just plot these 30 points and then try to guess the line. You just want to be precise about it. Okay, so that being said, here are kind of your 3 action steps at this point. And I don't know if do you do the booklet or what do you do?
Yeah.
Oh no, not the book.
The meat notes, right?
Yeah.
Yeah.
Oh no, I'm talking about like your coaching booklets.
No.
Oh, that's okay. Okay. So it's three things. So specific to Unit 4, use the graphing utility.
Okay. Sorry. Take out unit 3.
Yeah. 2, we'll adjust the IP to monitor for misconceptions on the conceptual side and not necessarily worry so much about the graphing. And then the third part, because now you'll have more time for that, you can focus on just like circulating to see student responses, as opposed to having to tutor them on plotting the points.
So have those guided questions ready, so when I approach them and they need some help, ask them, or if they have them understand how it relates to the problem.
Yeah, because then you can do it's an easier pathway to do like ask 3 before me, or something like that, as opposed to having to tutor every student on, hey, is this point right? Is that point right? Because that's a lot of work on your end of it. So if they have that taken care of, then they can actually think about the map. They can think about the why behind a line of best fits, or like, as opposed to just like trying to get the precision of the points, because they've already practiced in 8th grade to some extent. They've done the manualist part of it. They've already been frustrated about it once, so you might as well just get right to the graph.
Okay.
So let's kind of just sit through 413, and then let me see if I can find the CPM exit slip while I'm at it.
I have it.
Oh, you do? Okay, let's take a look at it.
Well, based on that suggestion,
Yeah.
they have one more to graph.
Mm-hmm.
The modification that we're making, we're going to have them create this table on decimals.
Yes.
And have the computer give them the equation.
Yeah.
And then analyze, okay, this is what, I don't know, I think this one's asking for residual as well. So they can calculate it more accurately.
Yeah.
Okay.
And it's up to you if you want to, how much you want to walk them through the function of decimals, but it is a pretty straightforward, it's pretty straightforward. It's literally, you just have them plot the table, plot y of 1 equal, and then the approximation mx1 plus b. It's like literally you could just guide them, I do, you do, I do, you do, we do, or even just like do it like a guided note. And they should be able to nail it.
Okay.
Whether you want to do it individually or groups, it's kind of up to you. We can kind of discuss that.
Okay.
All right, so let's kind of sit and kind of hash this out.
This is 413.
Uh-huh.
This is the one with the bullets right there.
Mhm.
The human view.
Yep.
The bone measure is amount. So based on the statistic information, they're given a table here. So that when you're finding like an outlier here, since by the point that this part is just not an outlier, but the one based on the line. Can we graph this? Some decimals together so we could have an idea.
Let me check one thing. Cool. Smart. to create it, just hit another. Yeah, I did the same thing, so.
Okay.
There you go. I didn't finish my
So the equation would be. Okay. And which one is the farthest point? I'm assuming this one?
Yeah. Wait, zoom in on it. You gotta zoom in on it a little bit.
Mm-hmm.
Oh, there we go.
It is this one, right?
Or is it this one?
So how do I, farthest from the line?
Yeah.
So, yeah, 24, 174. The procedure for this point, so we would have, again, what is residual?
Yep.
So here, we're looking at, okay, so would you suggest that they do it manually?
That they can do manually, or they
Okay.
can, obviously you have Desmos, which is a calculator in itself, so.
Right. But I think this one, what number is that? Sorry.
Oh, fine.
It's 30, 22, 24.
Mm-hmm.
So they would plug in 24 here, and then the actual, this is the 175, so it would be 175 minus whatever we get there.
Mm-hmm.
Okay, so that's
Yep.
that task.
Okay.
This is where we introduce the boundaries,
Yeah.
so the upper and lower bounds.
Yeah. Range of values for the possible heights.
So this would be a 1.5 and extra, so
Yep.
1.5 and extra.
Mm-hmm.
How accurate do these need to be?
I think for something like this, if you're within a couple tenths of a point, I think you're fine. Let's see.
So would they need to?
It doesn't have to be exact, especially given the parameters.
So this is my question.
Yeah.
Because if we do this online,
Yeah.
I'm gonna have to print it out simply because they would have to draw something that is parallel to that.
Mm-hmm.
And I don't know, again, it goes back to the question of our students writing an equation.
Mm-hmm.
So it's not asking them to write an equation just yet.
Yeah.
It just says draw two parallel lines. So from there, draw a line that is parallel to that.
Mm-hmm.
And to create your range values. How would we do this manually? Sorry, on the Desmos.
So for this one, range, let's see if it does it. I think your suggestion, Mike, like maybe you print out this.
Like I have it and then have them do it manually after. So
Yeah.
they explore online
Yeah.
and then, okay, here you go, this is a copy of the graph.
Yeah.
Now let's draw our parallel.
Yeah,
lines.
because one of the things that, I love CPM, but one of the things I always never liked was sometimes if you do A and B wrong, then you're kind of
Mhm.
screwed in C. So this kind of, in this particular case, that kind of prevents it. Bounds and decimals, let's see, you do. Oh, you can do, let's see.
Please report to the office. Please report to the office.
Well, they do have like a class activity you can do with this. I mean, you could just use the triangle method. Helps you get the upper and lower boundaries. Does it give it to you? Make the upper and I mean, to make the upper and lower boundary lines. Yeah, you know what? I would draw just because. I would give them a sheet of paper and just let them draw, just so that they have so that they can that they can kind of interpret it that way. If they want to use Desmos, that gives them a second way to do it.
Right, because I'm looking at this, maybe
Yeah.
they could estimate, because the slope is gonna be the same as this one.
Yeah.
The only difference is if you draw your line, then you're just estimating the line intercepts.
Right. I don't know if that's a bad thing.
Okay, that's
Create-
something for me to think about, if I wanna create, have them do it on Desmos or actually have it print out.
Yeah.
Or have both, maybe for those
I
students who
think
need
you
to have.
If you have time, give them both. I mean, if you want me to print it out for you, I can do that
I
too.
know.
Yeah, okay.
Perfect, so that's just that, and I think we need to find a difference,
Mhm.
and that's all, I think, for this one.
And just think about it, like, if you have the kids, like, literally just spend all their lives plotting this, their brain just gets tired at that point. And so rather than you having to tutor on this point, now you can actually talk about the more interesting questions in it. With your team, discuss the bounds of the data. Was your model useful? Figuring out whether a model is actually useful.
And tying it back to the context
Yeah.
of the problem, which is, in this case, the human and the phone.
Yeah, that's a much more useful problem to use in mathematics. Yeah. Okay, so I think we're in good shape for this. So I think, my one other push, and this was the kind of the third action step, and I think this is gonna be easier for you because I've seen you monitor before. I think now you can monitor for student responses versus monitoring for tutoring, which is what I did see today. And I think that's gonna be a lot easier in this, with the graph being done on Desmos versus being done manually. Okay, Ms. Rivas, I think we're in a good spot. So just to recap, congratulations on your 3-5. And then our 3 action steps, two of them of which we did here are what?
Modifying the lesson, and not spending time graphing it, just having them explore using Desmos.
Okay, exploring using Desmos to do the graph
And the equation.
and the equation.
And for this particular lesson, we're gonna print it out for them to continue with the lower bounds and upper bounds.
Yeah. So you're modifying the lesson, and then what are you gonna do as you're circulating?
Looking for student responses.
Yeah.
And having them make those connections with the context of the problem.
Yeah. So you're gonna intentionally monitor, looking at student responses, and then creating some form of a synthesis. Awesome. All right, Ms. Rivas, nice work as always. And cut. Oh, one other thing. I forgot to ask one other thing. How was this session for you? Do you have any feedback from me?
No, I think you helped me. I think the conversation that Mr. Estrada and I had, you answered that question, and I wish we would have approached you before.
Oh yeah.
And, no, you helped me understand how to move forward with the next lesson with those modifications.
Yeah. And I know I'm like on paternity leave and all of that, but I never mind getting a math question. Like those actually just kind of keep my mind rolling. So yeah, you guys can always do that. And like I said, I mean, I have complete faith in you guys making good decisions. Sometimes I'm just there as a thought partner, so shoot anything over to me.
Awesome, thank you, Nick.
No problem. All right, now I can cut this computer video. Hi Ryan. Hi Andrew. Bye.